So far in the chapter, we have learned various things. In the previous class, we had learned about different types of images. There we have learned that images are basically formed when reflection of light takes place from mirrors, right? Okay. But images can also be formed on a screen also. So we learned that there are two types of images. One is real image that can be obtained on a screen, like an image formed by a projector. On the other hand, we have a virtual image that cannot be obtained on a screen but can be obtained on a surface, like on a glass mirror, I mean to say. On a mirror it can be obtained. Then in the case of real images, we have learned that the rays of light actually converges after reflection. They actually meet at a point, while in the case of virtual image they appear to be meeting at a point. Okay. Yes, Salman, tell me. Salman, your voice really is not audible. I really can't understand what you're saying. Please use a headphone or something.
Showing some issues, so I can't open my camera.
Okay, okay. You can't on your camera. Okay, I get it. But make sure you answer the questions. Okay, and ask questions as well. Hey, Ibrahim. Sorry. How are you?
Sir, for coming late.
Okay. Ibrahim, I think you were absent in the last class. Huh?
No, sir.
No, no. I think you were actually absent. Oh, okay. Maybe I'm wrong. Okay. So we had learned about types of images where we learned there's a real image where the rays of light actually meets at a point. For example, the image formed by this magnifying lens right now, where the sun rays actually meets after reflection, after passing through, they actually meet. Okay. Then we had another example of real image formation by the projectors, right? While in the case of virtual image, they are formed when the rays of light appears to be meeting after reflection. Like for example here, the rays of light coming from this candle have got reflected from the plane mirror surface. Okay, but it appears as if the rays of light have met at a point. Okay, now after reflection, it appears as if they are meeting at a point, and that is how the image is forming. But that is not what's happening here. They only appear to be meeting. So that kind of image, which you can't obtain on a screen but can be obtained on a plane mirror only, right, or on other mirrors like a spherical mirrors, so that is called as a real image. Okay, Brahim, turn your camera on. Why others are absent today? Huh? Like a new chapter is going on, so everyone should be present. Okay. So further, we learned about the spherical mirrors also, right? Spherical mirrors are respectively of two types. One is the concave mirror, right? Another is the convex mirror. About the concave mirror we have discussed, like about the convex mirror we have discussed, they are curved outward like the back of a spoon. Right now, they are curved outward just like the back of the spoon. Like that, you can think of it. Okay, like the back of a spoon, they are curved outward. Okay. Further, they are used in vehicles' rear view mirrors. There it is used. It always forms a virtual, erect, and a smaller image. It always forms a virtual image, erect, and a diminished image. Okay, na? Then it gives wide field of view. You can look at a larger area in just a small convex mirror, as you can see here. Okay, na? So it is used for different purposes. It is used for security mirrors also, where you can look at a larger area. Okay, just at a glance, you can look at a larger area. Then it's also used in dental mirrors, shaving mirror, etc. Then we discuss about the concave mirrors also, where we learn that it is curved inward, right? And just like the inside of a spoon. Concave mirror, you can think of it just like sorry, just like this inside of a spoon, you can think of it. Then it can form real or virtual image depending on the object's distance from it, depending upon how far the object is standing in front of the concave mirror. Okay. Then it can produce inverted images also. and can form images of the same size, smaller or bigger in size, right? And thereby, and then it is used in spy holes. Spy holes are basically used in the doors, right now. In the doors, it is used. Like you can look across the doors, like who's standing in front of the door, who is knocking on the door. So from the spy hole, you can look, right now. So there it is used. It is also used in headlights also. In flashlights, it is used. In headlights, it is used. Okay. Now, there's one more interesting thing which I'm going to discuss with about the concave and the convex mirror. After that, we are going to continue with a new topic today. 1 second, please.
Sir, I actually checked about quantum physics, and you're right. It's
Uh-huh.
because of quantum physics itself that light can't be a straight line. It's because of Heisenberg uncertainty principle, which states that if we know exactly where a small particle is, that means that the particle, that its momentum is going to be very uncertain. So that's
Right
what. So,
now, right now, I will recommend you to focus on the syllabus. Once you'll be done with this now, if you once after you'll be finished with this and you get extra time, then you can discuss about that. Okay, no?
okay.
So right now, I won't recommend you to like it is. It's a good thing that you're interested, but right now, first finish the syllabus. All right, now after that, you'll be having plenty of time. Then we can discuss that. Okay. Also, others who haven't studied about it or don't have any clue, so they will get lost getting it. Ibrahim, what I'm trying to say. Others who haven't studied or haven't even heard of it, so they will find it very confusing. Okay, no. Getting it. It's not like I don't know. I won't want to answer. I want to answer it, but I have to like. You understand what I'm saying now? Like I have to take care of others as well. Okay, Prime. Yeah, Ayush. Yeah. See, there's one interesting thing about the concave and the convex mirror. About the concave mirror, right now, about the concave mirror, it is said that they are converging in nature. They are converging in nature. What does it mean? Sorry.
Okay, listen.
Concave. Pay attention here. The concave mirrors. See, concave mirrors are said to be converging in nature. What does it mean? It simply means that when the rays of light falls on it, so thereby after reflection they will come to meet at a point. After reflection, they all will come to meet at a point. Okay, na? Um, for better reference, I'll be taking this diagram here. Hold on.
Means convergent rays, right?
The rays will be converging. Convergent rays, you can say. Concave mirrors say that these are parallel rays of light that's falling on it. Okay, Ayush, Ibrahim, and Salman. These are the rays of light. These are parallel rays of light falling on it. As they will fall on it, so obviously they will get reflected, right? So after reflection, they all will come to meet at a point like that. Sorry.
Oh, so they're actually divergent rays?
No, 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 they are not diverging. Look over here now. All the rays of light as they are falling on this concave mirror, whose reflecting surface is curved inward. So after reflection, they all come to meet at a point. Try and understand this properly. They all are coming to meet at a point after reflection here. Getting it? And this point where they all meet at a point, that point is called as focus and represented by capital F. Understood that everyone what I'm trying to say?
Uh, uh,
Okay. Ayush, Ibrahim, Salman, getting it now? So the rays of light, since they
Sir, we can
come.
use a
Mhm,
sir. Uh,
mhm,
we can use a convex lens on this focus to make the light more.
mhm,
Like we could add a convex lens exactly at the focus so
mhm.
that the line would be straight.
Yeah, basically what happens in the case of the convex mirror, that the rays of light are going to diverge away in different directions. They are going to diverge. Here, they are
Oh yeah.
converging. Converging means to come to meet at a point. All right now. So they are. Some of you are so silent in the class. I think you guys are absent. Some of you are so silent. It appears as if you guys are absent. Salman, Ayush, what happened? Are you not getting it?
Can you hear, sir? Can you hear me?
Yeah, I can hear you perfectly.
Sir, sorry, like my problem was that it failed to connect to the mic, so I was
Okay.
connecting my audio with that, so it took some time.
Okay.
Now
Okay.
it
No
is
worries.
now it is clear, sir.
It is. It is clear. They're also called converging
Okay.
mirrors.
Sir, I was fixing my voice and
Okay. Because the rays of light, the rays of light after reflection meets at a point. The rays of light after reflection comes to meet at a point called as focus. Called as focus. So that is an interesting thing about the concave mirror. Understanding it, everyone? Okay. Further talking about the convex mirror. Convex mirror, you know that whose reflecting surface is bent outward, right now? The reflecting surface is bent outward. Like this is the reflecting surface, this one, right? So say that again in this case also, parallel rays of light are falling on it, suppose, right now. Say that these are the rays of light falling on it. 1 second. 1, 2, 3, 4, and let's say we have taken 5 rays of light like that. So they will appear to be meeting at a point, but they actually get diverged. They appear as if they are coming to meet at a point here. So this point again will be focus, capital F. But what is exactly happening here is that all these rays of light actually diverge away into different directions like that. Okay, now Ibrahim getting it and everyone?
Sir, like those divergent rays are completely aligned with those convergent rays that we thought would happen.
Mm-hmm. Yeah, like
Like
you can observe that.
they're like in line.
Hmm. While you see this one will come straight and will go back straight like that. Okay. So that is called as a, this one will be called as a diverging mirror, right?
Mm.
So convex mirror is also known as diverging mirror. Reason you have understood that the rays of light after pass after reflection, they diverge into different directions. All right, everyone, they diverge into different directions. Because of that reason, they are called as diverging mirror. Okay, now. So the rays of light after reflection from a convex mirror diverges, you understand, basically they spread into different directions, they spread out, right now. The convex mirror, it causes the parallel ray of light to spread out into different directions. Understood that? So the rays of light after reflection from a convex mirror spreads out slash diverges. Okay, thereby it is called as a diverging mirror. Hope that should have been clear to everyone here. Okay. Now there's one more topic that is about lens. We don't have to learn about that in much of detail, but lenses are also important. You know that lenses are used to cure eye conditions also. Right now, if someone is suffering from myopia or hypermetropia, some people can't look nearby objects properly. Some people can't look far away objects clearly. Some people can't look both the, whether it be nearby or far away objects, they can't look at it properly. So lenses are used to treat various eye conditions, right? Okay, no, so they are used for various curing various eye conditions. Okay, and they are of two types respectively, which I'll be telling you. So it's a transparent piece of glass, or nowadays we have fiber plastics also. Right now, that is also available nowadays. In fact, they are lighter also. So that has curved surfaces and can bend light rays to form an image of an object. Okay, no. So they are of two types. Okay, and uses I have already told you. They are
They're
usually
used in cars.
mm-hmm, to treat.
They're used in cars. They're used in what can you say? Eye lenses for people who don't want to wear glasses, and also for glasses.
Yeah, there also it is used. Right now, there are various purposes for which can be used. Right,
Yeah,
some of them are used in vehicles also. Right, so yeah, we have different
yeah.
types of lenses. Okay, so there are different types of lenses. I was saying. Okay, types of lenses. The first type is concave lens. Another is a convex lens. The concave lens looks like that, while the convex lens looks like this. Okay. About the concave lens, I will tell you in short. Like you have don't we don't have to discuss that much in detail. So as you can see, the rays of light are diverging away as they passes through it. They spread out, right? And like these are the parallel rays of light passing through it. Okay, since it's a clear glass surface, so the light rays will directly pass through it. But how it will spread out in different directions like that. Okay, but in the case of convex lens, opposite happens. It actually makes them to converge at a point. Right now, all the rays they come to meet at a point in the case of convex lens. So that was a small introduction to the concept of lens.
So
Okay.
they're actually like double-sided concaves. Like a concave lens is like a double-sided concave. Like in the
Exactly.
way.
Uh,
Yes.
like that also you can understand it exactly. Okay, now it's time to do some question. Answer these. All of you will be participating in this. If someone is not going to answer, I'll be.
Okay, sir. We'll go in order. First me, then the other two people, or in an order.
Okay, as you guys wish. So let's say you answer first, Ibrahim. Then
Okay.
go to Ayush, then to Salman.
Sir,
That's
can I
yes.
answer last one?
Last one, or at last you are
Yes,
saying.
sir. Yes.
Why so? Huh?
Okay, sir. No problem, sir. No problem.
Hmm. Follow
Okay,
the
I will
sequence
answer,
only.
sir.
Hmm.
Okay, so the answer for the first one is a mirror whose reflecting surface is curved inward like the inside of a spoon is called convex mirror.
What about you, Ayush?
No, it's concave mirror. It's concave mirror.
God keep reducing. Okay, Ayush, hurry up.
Yes, sir. 1 minute, sir.
Okay, Salman.
Sir,
Uh-huh.
sir, 1 minute. Like, I'm just confusing a little bit, sir.
We should not be taking 1 minute to answer this question, huh? Salman, huh? Convex mirror, you are saying. Okay, Ayush, what about you?
Sir, the sir A1.
Yes. Option number. Come on, Ayush. What are you saying? Option number
They are
A.
used making concave.
Mm-hmm.
Sir,
Concave mirrors.
Ayush, which is the correct option? Okay, see. Moments ago, we just had learned about the concave mirrors. No, what we learned, they are curved inward, right? Concave mirrors are curved inward, as you guys can
sir,
see here.
sir, that time I was having issues, so I didn't hear what were you saying.
See, about the concave mirror, we have learned that they are curved inward, just like inside of the spoon. Even in the question, this was also clearly given a hint. Even a hint was given that it is curved inward like the spoon. So that is a concave mirror, clearly, no? Hmm? That is a concave mirror. Concave mirror is drawn like this. Okay, it is drawn like this. The reflection is going to take place from this surface as the ray
Sir,
of
which
light.
question you asked me? Second or first?
Obviously, everyone was answering this first question, so you were also supposed to answer this one only. Okay, see.
Sir, I thought you were asking second one. Sorry, it's okay. So you can
Oh,
continue.
okay, okay. So that is the case of the concave mirror, whose reflecting surface is curved inward like that. Now you guys also answer to me. Concave mirror, does it converges the rays of light or does it diverges it?
It converges. It converges the laser.
Hmm. It converges it exactly. So
That
is the rays of light will kind of come to meet at a point like this, right? Good. Okay. Next question is a bit interesting one. It says a concave mirror forms a real and inverted
between
image
focus and center to curvature.
between focus and center of curvature. Okay, do one thing. This is a bit of off question actually. The reason being because this is taught in grade 8 and 9 actually. The thing is that there are terms related to the spherical mirrors like center of curvature, focus, pole, etc., which is not in the syllabus, so we will
Yeah,
skip
I
that.
know there are formulas for this also. There are formulas for this.
Oh, you have learned about that in the school?
No, we haven't learned about that, but I've just
Uh-huh.
heard about many formulas about this. That's why focus is a measurement. We can
Okay.
calculate focus also,
Yeah,
depending
you
on
can
the
you can
photo.
calculate the focal length also. If the object length and the image length is given, you can calculate that too. Okay,
Yeah.
but and the answer you were saying that is actually correct. That between focus and center of curvature is correct. Anyways, uh, others continue with third question. You also, yeah. The rear view mirrors of vehicles are made of.
Concave.
Sir, answer
But
B.
Mm-hmm.
well, we saw in the
Answer
slide
B.
it was
Answer B,
convex.
you're saying convex mirror. Okay. Salman, concave, you're saying.
So they're actually used in both, right?
See, it's actually the convex mirrors. It is saying the rear view mirrors of vehicles are made up of. So they are used made up of convex mirrors. Huh?
Rear view.
Yeah.
Oh,
So they provide a wider field of view, no? That will allow the drivers to see more area
oh, it's not
behind them.
front view.
Uh-huh.
Front view uses
Uh,
concave, right? Front view.
Front view, what do you mean front view? Basically, the rear view is
Like
like this is. Mhm.
like this part, like which you see in the front of you, that piece of big glass.
Oh, you're saying the one that is in front of you, overhead. That one.
Yeah, the one that is able to move and like it's connected to the door.
That is what the rear view mirrors are, no? Look at this
Oh,
image. That is what we call as rear view mirrors, like this one. That is a rear view mirror, no? In which it is written that objects in mirrors are closer than they appear. You will find that objects in mirror are closer than they appear. This is what is written over there. You ever thought about why it is written that objects in mirror are closer than they appear in the rear view mirror of the cars?
sir, it's
Because
because people might get into accidents if they just think that's the actual distance they're
uh,
with the object. So there's a high risk of
hmm.
accidents or negligence.
Yeah,
That's why.
correct. But the main reason is that this convex mirror, it creates a wider field of view by making objects appear smaller and farther away than they actually are. Try to understand this. Try to visualize it. It creates a wider field of view by making the objects look farther away, by making objects appear smaller. try to observe this thing when you travel in the car next time. So it will appear as if the car the image of the car or any other vehicle you are seeing in this is very far away from you, but no, it's the thing is that it's trying to shrink everything. It's trying to create a shrinked image so that it can give you a wider field of view, so thereby the object appears to be farther away from you. Understanding it, everyone, no? Right. So it's actually a safety precaution in order to alert the drivers that the objects behind them are actually closer than they seem to be. So that helps to prevent accidents, right? So we don't misjudge the distance. Okay, now answer this question here. The image formed by a convex mirror is.
The image formed by convex mirror is always
Yeah, you guys also answered it.
virtual,
Yes, sir, I'm
virtual and
trying.
erect. Virtual and erect.
Okay.
Sir, I think so, yes. Same.
Okay. Okay. Salman.
I told option B.
Option B. That is virtual and erect. Correct. Okay. No matter where the
Virtual
object is
and erect.
placed, virtual and erect. Option number B.
Oh, okay.
Okay. So no matter where the object is placed in front of the convex mirror, it always forms virtual and erect image, and also the image size is smaller. Understand that thing.
Yeah.
It is always smaller than the object. Okay, now option number B. A concave mirror is commonly used by
Dentists. Dentists.
dentists. You're saying,
Sir,
okay.
yes,
I
sir,
think so.
dentistry.
Mm-hmm. Okay, Salman. What about you?
Uh, Drivers?
Sorry, drivers. Drivers, like they will be using the rear view mirrors. Rear view mirrors are made up of convex mirrors, no?
Mm.
Right. So it is actually dentist, no? Huh? You know
Oh,
why?
okay.
Because we have learned, I have told you guys that when the objects are brought closer to the concave mirror, when the objects are brought closer to the concave mirror, so then it forms enlarged view of enlarged images.
Yeah, yeah, yeah.
You would have
Enlarged,
seen.
but like, it
Uh-huh.
gets inverted if we go too far away.
Yeah, it does.
Enlarged
Does.
and inverted is the image that is formed for a concave mirror.
Hmm. See, you will find like 1 second.
Yeah, we always see this in the dentist.
So you'd have seen it. So what you can spot here, let me take a relevant image here. That will help you understand it better. You guys take a look at this image here, this one, and then take a look at this one as well. In this, you will find that the view of the teeth is kind of the image of the teeth is a bit enlarged, so that the doctor can carefully look at it and will be able to diagnose the condition properly. If you ever had this unfortunate experience of visiting a dentist, so you will see that they will be first placing it just behind your teeth, and they will get a very large view of your teeth, so they can actually spot um, where this infection is, where the bacterial growth is taking place, like that. Getting it? So this is the image I was telling you, or you can take a look at this one as well here. There seems to be some error with this. I hope you guys can spot the one which I'm selecting now. So you can see how the image of the teeth is a bit enlarged. Right, Salman, Ibrahim, and everyone?
Yeah.
Okay, so concave mirror is commonly used by the dentist. Okay, while the shopkeepers, they will use which type of,
Select
they use
plain
convex
mirror.
mirror. Yeah, they will be using plain mirrors, particularly like the barbers, they will be using the plain mirrors. Okay, now in the barber shop, you
Yeah.
will sometimes in some barber shop there'll be a plain mirror in front of you and behind of you also, right? So
Mm.
shopkeepers, they will use a security mirror, right? Which mirrors are used for security purposes? Convex mirror. Remember that.
Security. Why?
Uh-huh.
Why is
Because
convex mirror used?
convex mirrors, like they will simply mount this convex mirror in one corner of their shop. Like this is a corner of their shop. Suppose that they will simply mount a convex mirror on one corner of it. Okay. Then what you know about the convex mirror, that it forms a wide field of view. It gives you a wide
Oh, okay,
field
okay.
of view.
So
Right
he
now.
just looks in the mirror and he sees
Huh.
any, and they are able to spot any person.
Exactly.
So
Suppose
Watchman can nicely sit down there.
exactly. So suppose this is a shopkeeper over here while sitting in his chair right now. He can simply look at this mirror and he can look at the entire view of his shop, like where the customers are, where the staffs are, etc. Right? So if
Yeah.
something wrong is going on in the shop, he can actually look at it just and will be getting an idea. Okay. So there also it is used. Now washman. So washman, what will the washman be using here? Like washman, you will see that they will always have, like during particularly the night watchman, they will be carrying a flashlight with them, a torchlight with them, right?
So they use convex or
No, no, hold on.
concave.
It's watchman actually. Sorry, I mistook it. Mistook it. Okay, now. So watchman will also use watchman. Like think about it. Like think about it for a while. What does the watchman do?
They like watch a really important place for the nighttime, and like they do it continuously.
Hmm. So they perform security duties, right now. Okay, they perform security duties basically. Okay. So what type of lens will a watchman need? Huh? They need to look at objects and people at a distance, especially in low light conditions. In this case, what they can do, like
Convex.
hold on. So they can like use binoculars sometimes can be used by them. Think about it. Or
They can use binoculars.
uh, or they will also need a wider field of view now. Watchmen, if they were to get a wider field of view, so they can keep an eye of everything going on in the surrounding, right? So in that sense, again, convex mirror.
Convex lens.
All right. Yeah, tell me.
Sir, it's all of this type.
Salman, I have told you several times, please use a headphone. Your voice is very low.
Sir, it's all of this type.
It's all of these. No,
Yes.
no, no. I was talking, question was about concave mirror. No. Watchman will use convex mirror. Okay. Driver will be basically using the rear view mirror to look at the
Which is
cars behind,
convex.
which is again convex now. Security mirrors, so that is also convex mirror. Like shopkeeper will be using security mirrors. So dentists use only the concave mirrors. So like dentists will be using the concave mirror. So only option number C. Hmm. Okay, let's get to learn. Sorry, one second. Let me have some water. So we'll be learning about shadows also. It's a basic thing. Okay. Talking about the shadows here. So shadows are, when are the shadows formed? Shadows are basically formed when the path of the light is blocked, right? When the path of the light is blocked, so thereby shadows are formed now, right, everyone? So when an opaque object will be placed in the path of light, so dark portion is formed on the opposite side of that object on a screen, right? And that dark portion which you are basically saying is called a shadow. Now, one more topic can be discussed here, that why can't like do the lights bend? So the answer is clearly no. Right now, one of the reasons why you get to see sharp edges of objects now is because light does not bend actually. Okay, suppose if an opaque object is placed
Yeah, like
here.
if like light was not a very if light could bend and
Mhm.
refract in air, then that means we would not be able to see it properly. Like it would be blurry on the edges. It would be blurry.
Suppose there's a wall here, right? So on the wall you will be getting a shadow of this. Suppose you get a shadow like that, you'll be getting a shadow of it. Suppose. Okay, so you can see the edges also here, right? You can in fact see the edges of the shadow also, right now, everyone? Okay,
Yeah.
right. So an opaque object is placed in path of the light, so thereby a dark portion is formed just behind the opaque object. Okay. Also, the reason why shadow is formed and why you get to see the sharp edges of the object also is because light cannot simply bend around the object. Suppose if an object is placed like that, so it isn't like light is passing and it will bend around it like that. No, it will simply reflect away. What will happen is the ray of light will simply sorry will reflect in some direction. Okay. Now the size of the shadow, the contrast of the shadow, right? It depends upon various factors. So the size of the shadow depends upon the distance of source of light and on the angle at which the light ray is falling on the object. Meaning that, like you guys would have observed this thing. Suppose, for example, if I were to put a flashlight on my hand, okay, now if I were to put a flashlight on my hand like that, suppose 1 second. Suppose you would have done this as a kid. Like if I were to flash light on my hand like this, so on the other side of the wall right now I can see some shadow. Right now, as I'll be bringing my hand closer to this flashlight, I can clearly see on the wall right over here that the size of the shadow is becoming bigger,
Bigger.
right? So when the
That's how convex and concave
Mhm.
also play. They also play a role here.
No, you will get confused. Don't bring that topic here. It's a different thing.
Okay.
Okay,
What
so
about like
basically,
a light that comes from concave lens? What will happen?
yeah, in that case it will be like converging. In the case of convex lens, in the case of concave lens, it will be diverging. I'll be showing you the animations and videos for that. Right now, try to understand this once again. So I'll be bringing my hand closer to this flashlight, so the size of the shadow on the screen, like on the wall, will become bigger. So thereby, when the distance between the source of light and the opaque object, this hand here is, I hope I'm visible, right? So this hand is an opaque object. This is a source of light. As the distance is decreased, so the size of the shadow increases. While I'll be increasing the distance by moving away my hand, so thereby what will happen? The size of the shadow becomes smaller. Okay. Then there's one more thing. If I were to slightly change the angle also, the angle between my hand and this flashlight, so that will also affect the size of the shadow. That you can clearly observe during the daytime. Right now, as the angle at which light falls on the opaque object changes, so thereby the size of the shadow also changes. Okay.
Because that's the only part where there's not gonna be any light. So that's it.
Mm-hmm. Okay. So it depends on the distance of source of light and on the angle at which the light rays fall on the object. If the source of light is closer to the object, a larger shadow is formed. When the source of light is far away, then is larger shadow is formed. When the source of light is far from the object, then smaller images formed. All right. Further, in order for the formation of shadow, you guys clearly know that three conditions are required. First, there has to be a source of light. Okay. Second, you need a opaque object. Third, there has to be a screen on which that shadow will be obtained. Right now, getting it. So an opaque screen is required to form a shadow. If there is no screen, then no shadow will form. Then color of shadow is obviously always black, and a shadow casts the shape of the opaque object only. Right now, the shadow will not cast the shape of the light source here. All right, as you can see here. Then size of the shadow, it varies according to the presence of light coming from the different angles. So you know that during the noon time, your shadow is the smallest, while in the morning and in the evening, the length of the shadow is longest. While taking a walk during the morning or in the evening hours, you would have noticed this. Right now, when like the sun's rays will be falling on you behind, so then you can clearly observe this. Okay, everyone. Okay, but shadows are not formed here. Like these are some small scale examples of shadow formation right now, but we have some bigger examples. of lunar eclipse and solar eclipse. So let's learn about that, like how are they formed, what are they. Okay. Sorry. See, talking about the eclipses, so eclipses are basically formed on the basis of rectilinear propagation. It's formed because of the concept of rectilinear propagation, meaning that the rays of light always passes in a straight line. Just like moments ago I told you that the rays of light always passes in a straight line. If an obstacle comes, it reflects back. It does not bend around, right? It does not bend around. So something similar happens. Also, the property of light,
Sir,
where we have discussed it
the
travels in a straight line, it is called as a rectilinear propagation of light now. Yeah, tell me.
so actually in the laws of physics, in one of Newton's law, it also like if light was able to bend, then that means that it will break the laws of physics because it states that any object like it will its inertia makes it stay in a straight line.
I didn't catch that. Please repeat again.
No, so like Newton, Isaac Newton, he made
Hmm?
laws on inertia, and he was the one who told about inertia. So according to inertia, photons stay straight, but
Hmm.
I've heard that photons don't have any mass. So how does inertia affect them?
Okay. So you're saying that photons don't have mass. So how do inertia affect them?
Yeah,
Okay. Mm, how do you saying uh how do inertia affects the photons, right? Mm,
yeah, because like inertia, it makes weird effects. Like
mm,
for example, in a spinning top, it makes that weird effect that I want to stay
see.
straight. Same
See.
with photons. Photons want to stay straight as well.
Mhm. See, like in the Newtonian physics now, in the Newtonian physics, the classical physics, that is the Newtonian physics, their
Yeah.
photon is a massless particle, as everyone knows. So since it does not have any mass, so it does not have any inertia simply. Right now, in that sense, if you were to talk about
Yeah.
Newtonian classical Newtonian physics, so thereby there it does not have any inertia, so it does not show resistance to change in its motion. Right now, getting it, because of its almost like zero momentum, it won't show any resistance to change in its motion, right? So that is the thing. Like in that it is inertia. How do we define that? Inertia is defined and as an object's mass and its resistance to change in its speed. Now, as per the first law of motion, there you will be learning that
Yeah.
in the first law of motion, what do we learn? We basically learn about the concept
Or inertia.
about uh-huh,
That a moving object wants to stay in motion and an object in
uh,
rest wants to stay at rest.
hmm,
Or inertia. That's called
right
inertia
now,
as well.
right? So Newton's first law of motion is also known as the law of inertia. It basically says that an object will remain at rest or it will remain in uniform motion or in a straight line unless an
Unless
external
an
force acts
external
upon it.
force is acting.
Okay, so
Like
that
for
is the thing.
example, air resistance. Air
Mm-hmm.
resistance stops a ball from continuously a small
Mm-hmm.
feather from
Mm.
going at a typical speed. So like
Yeah.
that.
Okay. Now let's get back to this topic again. Okay, now. So talking about eclipses, right? So eclipses are formed on the basis of rectilinear propagation. Like they will be formed, particularly here, it will be formed when the sun, moon, and earth, they will be aligned in a straight line. So they are the shadows will be formed naturally when the moon, sun, and earth are aligned in a straight line. Okay. Sometimes the moon may come in between sun and earth, and sometimes the earth will come in between of moon and sun. So different types of eclipses will be formed. Let me first explain about the solar eclipse first. Okay. See, a solar eclipse happens when the moon passes between the sun and the earth. Like moon is doing rotation and revolution. It is rotating, doing revolution around the orbit, around the earth right now. So there will come a time period when it will be lying exactly in a straight line where the sun and earth will also be. Right now, so the moon orbits the earth and sometimes comes exactly between the earth and the sun. When this happens, the moon casts shadow on earth's surface. Like say that these are the rays of light. Hold
Sir,
on.
actually, sir, when I was small, I used to think, haha, it's so funny. How is it even possible that a complete shadow is made? But when I saw eclipses, I was amazed that
Mhm.
complete shadows are made. I thought about it and then I realized that actually it's about the distance. So the
Mm.
distance affected the light. So the
Mhm.
light naturally converges towards the earth. So the moon like reflects that light. So that's why we're
Mm.
not able to see any of the light of the sun.
Mhm. Right. So when this thing will happen, so moon will cast a shadow on the earth's surface. Right. So what exactly happens? Let me explain you with more clarity. See that these are the rays of light that are falling on the moon. Okay. These are the rays of light falling here. And you can see these are some of the rays of light that have actually reached the Earth's surface. See that? Well, some of them are falling on the moon and are not reaching the Earth. Hope everyone can understand that clearly. Right, Salman, Ayush, and Salman and
Yes, sir.
Ibrahim. Okay.
Yeah.
So there will be this region here on Earth, right now, where the eclipse can be seen. I mean to say from where the eclipse can be seen. From where shadow of the moon is casted. Right now. And in order to see the total eclipse, you have to be in the darkest part of the shadow. Right now, you have to be in the darkest part of the shadow, and that darkest part of the shadow, it is called as umbra. UMBRA, umbra. What is it? It's the
Yeah.
darkest part of the shadow that is casted here on Earth. Okay. While in other areas, you will see a partial eclipse or you will see a lighter shadow. And that is called as like if you are suppose I am living over here right now. So suppose I am living here. So I will see a lighter shadow and that will be called as penumbra. Penumbra, penumbra.
Yeah. Those penumbra and umbra are different places of a shadow.
Mm-hmm.
Penumbra is actually the blurry part, and umbra is the darkest part, which is the
Yeah.
center. Because
Ex-
light somehow seeps through the sides,
Mm-hmm.
and that makes the penumbra blurry
Mm-hmm. Right. So that is the
because
thing.
it's a mix of darkness and lightness
Mm.
and light.
Right.
That's
Now, this solar eclipse is also of different types, by the way. Sometimes you will get to hear that this will be a total solar eclipse. Sometimes you will hear partial solar eclipse like that. Okay. So we just discussed about it. Hope that much is clear to everyone right now. So basically, what is happening here? The darkest side of the moon is facing the earth. During the solar eclipse, the dark side of the moon is facing the earth right now. And this phenomenon particularly takes place on a new moon day. This phenomenon usually takes place on a new moon day. Understood that now? Okay. Then moon's shadow will form a total solar eclipse on the region of the earth where the umbra of the moon falls on it. While the partial solar eclipse will take place on the region where the nimbra of the moon shadow falls. Understood that now? So like if I am here, so I will just see a partial amount of the solar eclipse right now. Like take a look at this one here. This appears what? This appears as if that person was in the umbra right now. Getting it? This appears to be in the darkest region of the shadow. A person who is in the darkest region of the shadow, they will be able to look at it quite like that. Like it should be a bit more kind of like it's a bit more visible here, right? But if I were to
Sir,
cover
like
this much portion
without
also,
glasses.
sir.
huh?
Actually, sir, like
Tell me.
also, I learned that when we look at the sun, our
Hmm?
pupils they adapt to the light, the UV light, so it doesn't alter. But when there's a solar eclipse, uh, it tricks our brains, so we don't like try to change the way our pupils are. So like that allows UV rays to enter our eyes, and we get eye damage, right?
Okay. First of all, the thing is that We can't look at the sun directly. One of the first thing is that you can't look at the sun directly. Why so? Because
So, like, meaning that you try to protect yourself at the maximum if you accidentally do for 1 or 2 seconds.
see, let me just complete the entire thing. What I'm trying to say here. Okay, now see, basically the thing is that the people you are basically mentioning here is basically a kind of entry source, like it's basically kind of a hole in the eye through which light enters. Right now, it
Okay.
becomes bigger and smaller in size. So that's why suppose right now if I have a flashlight in my eyes, so I will see that the people will become smaller in size, so that it will decrease the amount of light entering in my eyes, so my eye does
UV
not get
light.
damaged. Not about the UV light. It is basically so that my eyes don't get damaged. But suppose if someone were to look at that, were to look directly at the sun, so sunlight is quite harsh. If that much amount of light were to directly enter into our eyes for a significant period of time, so the person will like the eye will get damaged in that case, right? Also, as you're mentioning that it has UV rays also. Sun emits a strong UV rays and infrared also. So looking at the sun directly even for a few seconds can burn the retina actually. Sometimes if it has a strong amount of UV rays, it can burn the retina, right now. So the person will be suffering from blindness also, right? That is the thing. Also, the retina, na, it does not have any kind of pain sensors. So this damage is going to
Yeah.
silently happen. Okay, na? That is the thing. While there are safer ways to watch a solar eclipse, you should be using solar eclipse glasses, right? And which are safer to use. All right. So that is the thing. Now we have the lunar eclipse. Okay. So talking about the lunar eclipse, it will occur when the Earth comes in between Earth and Moon. Right now, when the Moon, the Earth, and the Sun they align themselves in a straight line, so thereby the shadow
It's
of the
kind of
Earth will
like
fall on
smallest
the.
to largest. It's kind of like smallest to largest.
Oh, like that, you can see in the ascending order they have arranged themselves. So thereby the shadow of the Earth will be casted on the Moon, right now, and that phenomenon will be known as lunar eclipse. Okay. Then the total lunar eclipse will be formed in the regions of the moon where the Earth's umbra will fall. Right now, getting it. While partial lunar eclipse will be formed where the Earth's umbra will form. Understood that, everyone? Tell me if there's any question about it.
No, sir. Understood.
Sure.
Understood now? Good. Now we are going to learn about the laws of reflection. If that much is clear, we'll be learning about laws of reflection now. See,
Refraction is the opposite, right?
we can't say that as opposite, but that's a completely different phenomena, right?
Okay.
Uh, The first, before we learn about the laws of reflection, there are some important terminologies like incident ray, reflected ray, normal, etc. Okay, say that this is a plane mirror of light. Now, this is the incoming ray of light that is falling on it. So, that incoming ray of light that falls on the reflecting surface, that is called as incident ray. After falling on it, it is going to get reflected, and that reflected ray is this ray is called as reflected ray simply, right? Now,
Yeah.
to understand the law of reflection conveniently, what we do, we draw an imaginary line. We draw imaginary line. This does not actually occurs there. Is not something that is there. Like we basically draw imaginary perpendicular line to the reflecting surface. Right now, at the point where the incident ray has fallen. This is the point where the ray fell. So at this point, we draw a imaginary perpendicular line. So that is called as normal. Hope everyone understood that.
Sir, so like I also realized that it's kind of like an equation. If the incident
Hmm.
ray becomes bigger, the angle of reflection will cope with it and also become bigger.
Hmm,
So
hmm, hmm.
if one becomes big, the other becomes big. So like it's kind of like an equation.
You're basically saying something that is related to the first law of reflection. Okay, no, you're saying something that is related to the first law of reflection, actually. Okay, see, 1 second. So you will notice here that angle of incidence is the angle that is formed between the normal ray, between the normal and between the incident ray. This I here is for angle of incidence in short, while the angle of reflection is the angle formed between the normal line and the reflected ray. Okay. So in principle, they are always equal to one another. They are always equal to one another. So that is, in fact, the first law of reflection. First law, which says that angle of incidence is equal to angle of reflection.
Reflection.
No matter where the rays of light are falling on a plane mirror, it is falling on water, falling on a rocky surface, falling on a wood surface, etc.
It's like a universal
It's
property. It's
yeah,
a
it's
universal property.
yeah, universal law we can say, right? So that is angle I is equal to angle R. Okay, no? Angle I is for angle of incidence, angle R means angle of reflection. Okay. There's one more law, but you don't have to study about that. But I'll be showing you an animation related to that in the next class. Okay. Now, in the next class, there are a few more topics. There are many more topics left to be discussed right now. Like we have to learn about lateral inversion of the image. Like if you were to raise your right hand, it appears as if you have raised your left hand in the mirror.
Yeah.
So that will be it for today's class. Okay, there are a few more interesting things to learn about, by the way. We even have to learn about how the rainbows are formed right now, how the rainbows
Yay.
are
That's my
formed.
favorite part of every year.